Привет, Positive Hack Days.
Hello, Positive Hack Days. So you may be thinking it's Saturday, day off, and you still have got to sit here through a boring presentation. Name is Sergey Gordeychik. Over there you see my partner Alexander. And we'll be talking about something very boring, like scanning the whole of the internet. Now, if you want to grab some swag, I've got this. It is our tradition that after our presentations, we answer questions, and I've got, 3 very nice bits of swag for those who ask great questions. Okay. So, analyzing the internet, it's high quality, fast, and cheap. So, Alexander Rudikov is working with me at CyberArk, and yes, we both are masters of what we call dendrothecal engineering. It's like making stuff out of shit and sticks. Sometimes we don't have enough sticks though, but that doesn't matter too much. So, is there an on-off switch for the clicker? Okay. So all the tricks that we are going to demonstrate here have been performed by professionals. So if you're going to say, well, these guys did that, we are therefore allowed to do the same, we are going to have plausible deniability on that. So although we will be talking about machine learning and neural networks, we are not going to give you prompts for ChatGPT or QN, more or less. So previously at Positive Hack Days, so at CyberArk, we usually talk about what we did for Russian Shodan, also known as Balalaika, also known as Skipper. Now this is something we have been maintaining for the past 3 years, so everything I am referring to here can actually be found in our previous reports. This is in fact the 15th Positive Hack Days where I'm making a presentation. And it sounds like, quite a lot of times. Maybe I should call it a day here. So, let me explain what we are trying to achieve. Now, we want to have like 1.7 by 10 to the power of 19th ports, so want to collect this. Now we want to collect about 400 million domain names all across the internet. Now this is again like 1.6 by 10 to the power of 9. We also want to detect software and apps, and we are talking about like 15,000 different titles out there. Also look for outdated soft and vulnerabilities and a bit of IPv6. And in the Russian segment of the internet, we want to be able to do it in a single day with 1 gigabit machine and maybe 10 machines like this for the whole of the internet. Now, there are different ways of getting such a job done. Now, the first one is that, the Hulk way effectively done by or used by so many people out there, where you grab so much, hardware and software, and then you send trillions of packets all over the world, and you see them abused or whatever. And we tried doing the same, and then we realized we gotta be smarter. So the point we were trying to make was that, we wanted to hit more targets rather than shooting in the dark. Sometimes, it obviously looks like, we're showing off and to no avail, but sometimes it does work. So we become kind of a killer app. Or, we're dancing the Gattaca style. So, last year we talked about the usage of machine learning for port scanning, or rather optimization of port scanning. And some of the key studies that we reference are shown here, and they do underlie our own research.
Одна из них GPS,
So the key study called GPS here.
соответственно, сканера ISM Censisa.
So they use the ISMA census scanner. And another one, a very good one, even if I say so myself, is iPress, because GPS was running those huge matrices, while iPress is actually using smarter logic. So we covered that. If you're interested, you can check out our previous reports, or, just read the initial studies. So there is some math inside, and I will skip it. Because, I think that, except for the few people who love hearing about mathematics, everybody else feels pretty bored when the speakers talk math. So, over the past year, we have seen a substantial breakthrough. Now, the standard task you have when you're trying to scan large volumes is that you have to process lots of data like IPs and ports of applications and so on. Usually when you have to plow through so much table data, standard boosting works reliably well. Unlike, say, generation of a natural language, where deep learning is positioned to play a very important role, but here, your classic predictive models are still doing a great job. And now, in 2025, we are witnessing an important change. There are several neural network architectures, in particular table transformers, which seem to exceed your regular run-of-the-mill boosting and provide some very good results. I won't go into the details, but I am providing the links here. Pleasantly enough, one of the links will take you to a study done by Yandex Research, and that one was indeed very, very high quality. Indeed, we are actually leveraging their findings. Now, this is not what we've been doing. This is like what we found in the public domain, usage of transformers for OS detection. So Nmap minus O gives you like a fingerprint of the operating system. So you are sending packets to different TTLs, and that enables you to predict the OS. So they did it on a table transformer, which is effectively a predictive model. There is a gap here, however. The model dates to 2021, but the article itself is 2025. And still, it's interesting that modern machine learning is finding its way in cyber security world. So this is what we found, and we're able to apply in a pretty nice way. So if you're dealing with pretty large sparse matrices, there is a great way to optimize them for Python. Well, most machine learners use Python most of the time, don't they? So I am highlighting now in red that, in really sparse matrices, where sparse stays like 1,000 or less, this particular library gives you a great increment speed-wise, like 3 times faster, 400 times faster. So if you gotta do your parsing, I seriously recommend it. So that was sort of science. Let's now talk about results. If we're talking about the Russian segment of the internet, and that's the focus of our research today, we currently scan about 330 million pairs of IP port pairs. Compared to the address space of the RUNET, it's like 0.01%. So we have 47 million IP addresses. You then multiply it by 64K, and I'm not even gonna pronounce that value. So we scan like 1 pip of that space, and there we can find 4.36% of live services. Now that's not too much, you may be thinking, right? But if you brute force the same 64K ports, you will actually identify way fewer, like 48 like 100,000ths of a percent, which is a great optimization. Well, you don't scan too much, but how often do you hit it? Compared with the brute forcing method, we hit like 99%. So with this optimization, we miss out on 142,000 IP port pairs, and at the same time, our predictive model runs 3 times faster than the scanning itself, which means that we can be predicting on the fly using the incoming data, meaning that, we can keep augmenting it. In order for the whole thing to work, we have developed our own tool called Stateless for TCP. Now, you may be wondering why, given that we have Masscan and Zmap, but they do their scanning over rectangles. So you actually indicate IPs and sitters, and you and then you sort of sicken them. And then the prediction gives you, a pretty curvaceous shape, because obviously there will be different ports and different IPs used. So standard scanners simply will not be able to support that. That's why we have developed our own scanner, which uses this sequence approach. So it will calculate the hash of the port number and will therefore be able to recognize the responses to its SYN request, and will drop everything else. Now, we've also added there detection of spam traps or honey traps. These are, the nodes that will be responding to pretty much any sick query. So if you've done any scanning, you probably know that if you do your 64K scanning, like 97% of all responses will be coming from those spam traps. There are more nuances if you're interested, but I'll happily battle off. So, stateless for UDP is something that appears unique. We have not been able to find anything like this. Doing stateless for UDP is not difficult because, for TCP it's easy because you have CNAC there, but with UDP you don't have CNAC. You gotta send a probe, and there is no guarantee that the server will respond. And you cannot really insert any magic there that will help you identify whether it's live or not, but we did it by building the magic into the port number. So the way we do it is that we send several probes, and the center port number we use to calculate a simple hash, and then we add a seed to it to add a bit of randomness to that. So address of the sender and port number. So when we get a return, and there are not too many probes, like several hundred, no more, and then we see if, hashes match, then it means it was our packet sent, meaning it's not some DOS attack. We were afraid there would be collisions. So far, we have not seen anything like this. Now, it's only, unless you are Positive Hack Day's website, which seems to be going through, a sine curve in terms of availability, you shouldn't be suffering too much from DOS. Now imagine that you have scanned 256 ports, like the most common ones. You have identified the OS is running there, maybe something else. And then you want to predict which ports can also be open there if I know that the device is a Cisco. And this intuition actually makes a lot of sense, particularly if you're a pen tester. So you will know, okay, this is such and such device, say a microtic device. Which means that port 2000 will be open there because there is a particular service running there. So we decided to feed all this logic to a model so that it can train on the results of a good scan. And then it should identify for us some dependencies between port numbers, operating systems, specific protocols, and specific types of software. So, for example, you can say port 135 is open here, it's TCP and Microsoft Windows. What kind of other ports will probably be open there? We say Windows RCP. There will be other vanilla or like standard ports you can expect to be open. I'm not saying it's easy. It's in fact more difficult than just, checking specific port numbers because you have more features built into it.
Маленькие циферки внизу, посмотрите, насколько
Now the fine print there actually shows how sparse the matrix is. You see the density value.
матрица IP-адресов.
Now that's very little, right?
Соответственно, если
So everything else obviously is zeros, right? So if you
не знаю, bias, градиентный бустинг, у тебя большинство...
if you do some bias gradient boosting on it, most models will tell you, I see no data there. It's just, air, hot air there. So we decided to do two things: cat boost, and the other one is like
Взвешенные матрицы, которые вот используют...
using weighted matrices, the ones you would probably use for predictive models.
Да, там есть несколько оценок, которые ты сделал, и тебе...
So you know how they do it in the movies,
На самом деле задача, мы их сжимаем...
where companies like Netflix tell you what kind of movie you'll probably appreciate. So we are doing something similar here. You may call it deep learning if you want, for prediction purposes, and the results are pretty good, although not ideal.
56 портов натренировать.
So with data for 256 ports, we've been able to train our model. It does provide predictions.
1024 портах, которые нужно...
Then, for 1024 more ports that need to be scanned, we do the scanning and we get 0.75 out of 64K that we would need to brute force otherwise. And this way we are saving about 70% of traffic that we would expend had we been brute forcing it. But I do want to have it at the level of 97, right? So help needed. If you have ideas,
Рекомендую.
please talk to us, okay? We'll be happy to have your feedback. And here I want to hand it over to Alexander, who's going to tell you how he became Rambo.
Давайте зафиксируемся. Мы умеем
Okay.
сканировать.
So we know how to quickly scan the Runet, or the Russian segment of the internet. But can we actually see a lot when we're doing that? There is no answer to this question. There is so much information related to web services out there. And the logic here is pretty simple. We send a probe to a web service and it responds with a default page. At this stage, we know nothing about virtual hosts, and we are badly interested in this kind of data. We want to see it. We want to, get our fingers into it, and we don't want to overpay for that. What else do we have for that? We've got an internal service called passive DNS, which is effectively a cache of the internet DNS. From a technical perspective, it's a large table for about several billion entries where there is an IP address and a matching domain name. So we have scan results. We also have a snapshot of the DNSs. We just need to match them. So we augment the IP addresses with this stuff. Then we need a tool that will contain all that, and we'll be able to sort of crawl across this array.
От Project Discovery.
Very quickly, we settled on a Project Discovery utility as the one meeting our needs. But that was just the beginning. We generated, a range of targets, and we got 180 million entries. We also decided it would be a good idea to record the headers and response bodies. 15K proved to be the right size. Now we're also recording information on certificates, network addresses, some technologies. Then we launch it on a single machine. So the whole system was running for several days, and it told us, okay, I'm done. And we see that we have like 1 terabyte of results, which is not a colossal amount of information. You can certainly work with it. However, since it's HTTPX, it effectively creates lots and lots and lots and lots of files in the same folder. So if you simply move these files from one location to another, that's quite an activity. So what can we do? Are we like the only people who have this issue? Obviously not. There are big guys out there that keep addressing this issue. I'm talking, for example, about search systems.
Различные
So we decided to read some public reports on that subject, and we found some reports by Google and Yahoo that proposed a solution to that.
Similarity hash. Что такое
This is something based on the so-called SimHash or similarity hash. This is a cryptographic hash
блока текста, который отличает
designed to sort of match two somewhat similar blocks of text and bring them to the same value. Apparently, Project Discovery people have been thinking about it because HTTPX does provide for SimHash.
его использование, его
Now, the specific nuances of the algorithm there are special. We had to re-engineer it, and we also ended up sharding the data coming from HTTPX into something that works better for us. So we launched it, and in the end, we got 130 gigs, which is much better. So we put this data into our system, and we start cracking it. And if you've ever dealt with hashes, you will know exactly the kind of problems we run into. I'm talking about collisions, and these collisions were pretty critical. Because, you know, the same hash there
разные ответы, да, проецировало в один и тот же
provides, would actually project into the same hash pretty different entries. We thought of different ways of dealing with it, such as grabbing another SimHash function, and that would have taken quite some time. So we decided, well, how about we just expand the value space of SimHash? So we took the same function, we kind of doubled it, and then we played with its internal logic in order to sort of store the properties of SimHash. Then we combined the two. We said, okay, this is a good SimHash now. Let's rock and roll.
большое, как на первом.
It did not provide the same kind of improvement as we had the first time. So, you know, the ultimate size is 200 gigabytes. And some collisions are still there, but the collisions that were previously critical are no longer seen.
Некая функция эквивалентности.
SimHash is effectively an equivalence function. So as a kind of side effect here,
Которые у нас есть, разделить на
what we can do is that the total volume of results that we have, we can clusterize.
кластеров видим.
So we started analyzing these clusters, and it turned out
Веб-ресурсов, которые мы
quite a lot of web resources we scanned hold no useful information. Many of these are like RS404 and landing pages made by registrars or useless response pages from cloud services.
мы забираем, мы загрузим в ClickHouse.
So we put all the results that we find into ClickHouse, and ClickHouse can do magic with analytical queries. That's why we asked ClickHouse to show the biggest clusters which have the minimum number of unique results. And this is the chart that we got. You should be able to notice here that we have a cluster of 10 trillion targets which hold only 2 unique responses. So we naturally decided that we're not going to scan them.
Это все
So we decided that, you know, before we sent our stuff for scanning, we filter this stuff out. By doing this, we reduced our scanning scope by 30%. Now we are scanning about 100 to 220 million targets. Only 50, maybe 60% of this actually respond. And since it's an ongoing process, you know, we scan the RUNAT all the time. And if new web services pop up, you know, within a week, we are guaranteed to discover them. We do not have a cluster. Let me stress again, we're using a single machine to do that. And we are using an algo that helps us minimize the number of abuses. 200 gigs is the amount of data you can actually store and process in a single laptop. Moreover, we find lots of interesting information in the process.
И теперь, когда мы
Thank you. Let's continue. Now that we have collected all this information, you know, ports and responses from web pages, the next standard task for a security professional is to do fingerprinting. Like learn what's inside, what kind of app, what kind of software. I guess you know all the tooling, so Nmap is the king for sure. However, Nmap is slow as shit. So
и Masscan NG.
We will be looking at Masscan and Masscan NG. Thanks Byzone for this patch, and it does a great job scanning very fast.
Фингерпринта, тебе вот
However, if you want to add fingerprinting module, you will still be struggling a lot.
мы ее тоже используем. Это у нас прям приведут.
Now, we often use the ensemble of ZMap, LZR, and ZGrep. This is what we used for the previous version of Balalaika.
LZR Z-Grab, которые
So fingerprints there are made, with LZR and ZGrep in Go, which is much easier.
хардкоженные в Apo-Guyse.
There is finally HTTPX with so much stuff hard-coded into it
Как настоящий.
that even fingerprinting is not properly supported. Now, being Russian engineers that we are,
Мы сделали свой Nmap, назвали его
we decided to develop our own Nmap. We called it cokmap. Must be cokmap because the company is called CyberRock.
это тоже шутка. Вот,
Yes. If you think it's a joke in English, it is. So the QR code leads to our presentation at OffZone, where we talked about it in detail.
моментов по результатам.
And here I should probably show you the results.
Масканом, например,
Now, if we are comparing to Nmap and Masscan
15 минут мы работаем.
on UDP 161, Nmap runs for so long, and we run it's much faster. These are actually old slides. So we do 820 protocols, comparable to what Nmap does.
На
Masscan
443
on TLS port 433 runs just as fast as cokmap in about 1 minute, but it does not detect integrated protocols,
и не детектит продукты, потому что он не строит.
and it does not detect products as it doesn't build the TLS pipe by default. So Nmap and cokmap do create the pipe, and therefore the results are pretty similar.
Cokmap в общий доступ.
We have been promising to make cokmap publicly available.
Доклад 3 дня назад, и
It's just that, our report was accepted for presentation just 3 days ago. We haven't had the time to upload it all to GitHub, but it will be there very soon.
одна проблема.
There is one more issue that pops up during scanning. When we are scanning, we don't care that much about ports being open in a particular IP address.
Какое именно программное обеспечение?
We are particularly interested in what kind of software is running there. This is usually done with product matching. There are lots of product matching tools, and they all work in a similar way. You've got a banners, you've got your regex, and you apply them one by one. So when you see a match, you will see, okay, this is such and such service. It is no problem if you are scanning the perimeter of your own organization, even if it's a gigantic one. But it will become an issue
На масштаб региона.
when you scale it up and you start doing it for the region or the country.
После прохода сканирования мы получаем
So, after a single scan here, we have collected about 1.5 million banners for port 80. And we have some like 15,000 regular expressions.
задачи,
I hope you see what I mean here. That's a quadratic function we're dealing with. So, for calculation, we will need like 8 hours. That's a lot. That's actually pretty expensive.
в сторону мы начали
It's a pain in the neck.
оптимизировать этот процесс.
So we've been thinking about ways of optimizing this process. Like, how about we have this, magical mechanism that will only apply those regular expressions to the banners where they will probably trigger something.
Смотрим на
Also,
регулярное выражение, то, как правило, в нем будет
if we look at a particular regular expression, in all probability, there will be like an important heavyweight string in it. In fact, we can go looking for substrings in those banners, but that would require checking for the version of the software, maybe some additional info. How about we actually merge these two methods?
выражение. вытащим эту самую весомую
In other words, we can take this important string from every regular expression and commit to memory which regular expressions were related to it. Also, we have this great algo for substring search.
невеселой историей в одну...
This is obviously Aho-Corasick. And obviously, substring search must be so boring that, nobody does it alone.
Быстренько перебираем.
So, you take a banner, you quickly go through all the strings, you see which of them are featured in a particular banner, and then you add it. You also bring regular expression to the table, so to speak.
Регулярное выражение. Это форма.
So, regular expressions are effectively done in formal grammar, which means that we can do an abstract syntactic tree for that, and voila.
Мы получили увеличение производительности не в
What we have in the end is a performance boost,
увеличение производительности. Здесь
which is colossal, right? We go from nearly 8 hours to 9 minutes. Shown on the right is the number of results every method provides. And you can see that brute forcing gave us 3.4 million results, while substring extraction coupled with Aho-Corasick gives us almost the same in just 9 minutes.
И более того, мы сейчас думаем, что и эту задачку можно еще решить побыстрее.
So now we're thinking this can be addressed. And, we are quite happy
Давайте немножко
with the interim results as they stand already. Now let's talk about scanning in more detail,
какую задачу мы еще решаем. Нас не только интересует
because we do have other tasks out there. Besides the technical composition, so to speak, we're also interested in, the interesting tidbits and facts, like, okay, this is such and such operating system, but which company owns this this asset?
методами Recon и Async собираем про нее
So we can use Recon and Async tools to collect such information, and based on this, build our database.
чтобы это сделать.
Moreover, we've got the tools to do it all.
Как мы вообще смотрим на сеть? Мы смотрим на сеть в виде
Our view of the network
многомерного пространства.
is like this. For us, it's a multi-dimensional space wherein network attributes such as networks, domains, IP addresses, and FQDNs are effectively the elements. Now, in every organization, obviously, these attributes will be linked. So every organization is effectively a subgraph in this global space, and we have tools for identifying connections. We have scan results, we have a BDNS, we've got whois,
Сводится просто к обходу.
which means that if we just explore this graph and we go deeper, we should be able to identify, which organization it is. Now, we can miss some elements for sure. We can also discover, some connections with, say, network attributes have got nothing to do with the organization itself. Say, it could be, a hosting service provider or a cloud service provider. This is certainly not something new. Developers of some other software, particularly those who are involved in reconstruction of the network perimeter, are doing something similar.
Его легко читать, но ровно до тех пор,
You end up having a nice graph
с разветвленной сетью.
as long as you are not looking at a company that has a very distributed network infrastructure. That's why we chose table representation as opposed to graph representation.
Эксперта, да, так как
It is automated, but we also involve the experts because
тех
we do need to do some filtration at every stage. We need to filter out the resources or the assets that have got nothing to do with a specific organization. What you see here is the workspace of an expert. So we do here the graph traversal,
подсвечивает.
and the system highlights whatever it can, identify right away as something belonging and not belonging to the organization. But then the expert needs to do their own checking with Google or whois. Like if it's a website, they can just open the website and see what kind of information is there. So this is some routine work.
Работает
And since it's routine,
момент достаточно неплохо, с ним справляются большие языковые модели.
It would be only logical to involve an LLM. So, we developed a little addition to the system, where we are effectively telling an LLM, see, we've got this organization, it has this network attribute. Please tell us if you believe that such a network attribute belongs to this organization. And now we give you tools so that, like, searching online and so on, and, checking who is, to give you, a stricter confidence interval, so to speak. And please be prepared to tell us why you think it actually makes sense. So, we want to fully automate it so that we don't really need to engage our experts in collecting this information on the organizations on the graph. Okay, let's continue. So we found ports. We have... I'm sorry, thank you very much, people from Project Discovery, for the great toolkit. We have been able to identify the organization, and we're doing all this in order to be able to patch up holes. So Igor Pervushin recently talked about our participation in a project called Cyber Resistant Region, something that's being run now in Tatarstan. So we are effectively, involved in that. They're trying to do, kind of a SOC across a whole region of Tatarstan. I guess you've all been using security scanners. Most security scanners have got a CPU to CPE where, a particular CVE apparently is sent to a CPE is sent to a database, and it returns, all the CV associated with it. Now, not all of them have got to be critical. When I developed my own security scanner, I was asked many times, like, can you please hack me using something that you highlight as red? And in most cases, you cannot do that because whatever is shown as red in CVSS is often, noise. You cannot really necessarily abuse it. So we have identified like 1,800 CVEs, like unique names for the specific region, but it makes no sense to tell people to, remove it all, because most of these vulnerabilities are noise.
And of course, we have these specific checks and exploits when you can just see it and identify it. Sometimes they're quite intrusive and there are not so many, but you can take those CP to CB outcomes and sort of like make them more real. So we filter them according to CVSS and by the temporal score, because we have our own database volume. And we've also made an AI helper. We call this Anatoly. It's a helper of the InfoSec analyst, and it marked all these 8,000 vulnerabilities. By the metrics, we call it real-world danger, which counts in availability of exploits and detects of different exploits and tools. Like our database is like very much like Volmers, but not public yet. So we are just throwing the whole context and saying and give it to me. And so we had like a very simple metric from 1 to 5. And if you look at the numbers, out of 8,000 with a level of 4, we have only 174. And CNVD, I mean Chinese ones, and also those red ones, which are critical, only 33. So we reviewed manually these outcomes, and it turned out that only in 10% of cases the expert evaluation did not match with the Anatoly. Anatoly is learning, he's like a human machine, the kind of entity is getting smarter and smarter. So much about the LLMs. A couple more things. I wanted to share you a couple more stories. What we are finding with this thing. We are finding some mass vulnerabilities in RUNet internet segment. And as a matter of fact, if you look at the BDU rating, we're not writing SciPy but if you collect all of our guys, we're ranking number 3 after Positive Technology Company. And it is not because we really enjoy or like looking for vulnerabilities, although we really enjoy looking for vulnerability. We just come across them because we're scanning RUNet, and in RUNet we have the full import substitution going on. I would like to give you a couple of examples of this import substitution. Once at a pen test, guys have found vulnerability in one system, and you would disclose data of millions of users. We went to a vendor, and vendor wrote through the stack very complicated and got a response that algorithm of encrypting signatures should be closed. You got to implement something. We realized, okay, it doesn't make any sense to us, even though we are quite professional. So we've given to the vendor several reminders and sent them the list of vulnerable hosts in the RUNet segment with a lot of state and government companies. And then we said, okay, we're going to disclose it. Like nothing is happening. We're going to disclose it. And then vendor came back to us. And actually, good job that they did, because they had a meeting with the technical guys where our pen tester said, this is how we close, okay, now it makes sense. Then why did you write all this about the encryption, signature encryption algorithms? Because he said, well, we had to give official response. So this company is very known in the field, and you guys have also had to deal with it and try to deal with some vulnerabilities. Well, this is my open kind of statement to the Russian vendors. Folks, the RFP has been with us for over 30 years. It's a communication between the researchers and InfoSec guys and the vendors. This process has been working effectively and efficiently. If a vulnerability is being brought to you for your product, listen to it and deal with it. If you do not understand it, ask. But rainforest puppy is amused and abusing Kirchhoff, which has sort of formulated the principles that the resistance of the cryptographic system should be dependent on the key, not on the protocol. And also, I'm also a bit concerned because actually I've realized that the first CV I've registered back in 2005, 20 years ago. I'm a superstar. Another interesting story which has reminded me older and gooder times of 2012, when everybody was trying to break SCADA. Back then there was a note that Aaron Portnoy, I think, when he was cooking turkey, he found 20 vulnerabilities in the SCADA systems. It's not a rocket science, but still it's something. And it was May holidays, and we did some barbecue, and the guys found a vulnerability in one of the web forum, and we had also sent this information to a vendor. Vendor did not respond, and we just check who has this forum, to understand the potential scope and scale of exposure. And one of the forum was owned by the developers. Like, developers are discussing interesting things. They were developing SCADA systems, and I love SCADA. So I came in there. It looks like those are HMI controllers that these guys were making, and they had like a firmware openly available. I opened this with a 7-zip, and it's a Linux. It's great. And then backend from the 1990s, and you cannot see it on the slide. You just take this and there is no checking of parameters, and basically the password in the cookies is getting back to you into your URL encoding. Like, you type in the password, it saves it in the cookie, lest anybody forget, like something from the 90s, And basically what we see, we're seeing that in the domestic software field, we have lots of vulnerabilities, and we need to be very serious about that. On the PH days, we've had many conversations about SSDL and things like that, and all this DevOps and things like that. And half of what is exposed on the internet, you cannot really post it on the internet. And I think that our challenge as white hats is to help vendors to be aware of that. And I'm asking vendors, please pay attention to reports, because otherwise you are framing not yourself, but your clients and your country. And especially what kind of organizations have to comply with very, very strict measures on import substitution right now. And eventually, I just wanted to say thanks to Positive Hack Days team for inviting us, and okay, this it was approved like a last minute, in a couple of days before the presentation. So I apologize for any possible and horrible design of my presentation. We just didn't have time to do the proper design. And also I would like to say thanks a lot to the whole Cyber OK team in our community, which has been making open source and contributing to it, because we're only frontmans, but lots of guys and gals who are also here, be it online or offline, they are heavily invested in that, and thank you all. And especially we are grateful to Arkady from Vladivostok. Well, thanks a lot, and it's my pleasure to answer any of your questions. We have 9 minutes, so somebody is going to get lucky and get 3 sets of our merchandise. Can you please help us with mics? Yeah, we need mics.
Да, смотрите, у нас, уважаемые гости.
Yes, dear guests, we have microphone stands on your left and on your right. Please come to the one that is closest to you on the left or on the right and ask your question. Thank you.
Привет.
Thanks, and hi. In the very beginning, you promised to say something about IPv6, and that would be great to hear, and how you decided to scan it, because usually you identify 64 grid, and you cannot just plainly scan them. Probably you need to think about how can you generate address, or maybe MAC address and MAC address of device. Yes, I got it. We simply didn't have enough time. We thought that we just didn't have time to prepare the presentation. You know, basically, there are 2 approaches currently. One is passive monitoring, and there is a database when the guys are just uploading their outcomes of passive monitoring. It's great, like a seed, like some kind of primary education. There are also ML models. We're using somebody else's machine learning models. And, you know, like when standard MAC address is like a organization ID, you know, they're being used, but usually it's like a learning tool, which then being brute forced. And it looks like you're scanning slice, you get a response, there you're putting a model, it gives you new predicts, and then you again do repetitive scanning. And you can ping us. I'm going to give you all the links, and we have like a implementation, in fact. And the second case, which we are building for our own purposes, and which is being used actually by Sensi's company, is take IPv6 addresses from DNSs and certificates, you name it. And basically, in Sensis, they are doing this kind of scanning IPv6. We're trying to combine. And also, you've mentioned certificates, which were recalled from CRL, what is called, like, you know, the website where they issue certificates. Are you scanning them also? Yeah. It's a registry of certificates, I believe, yeah. Yeah, you know what? Yeah, if I got your question correctly, indeed, we do monitoring of the flow of certificates which are being issued, and they are being added for the scanning purposes, if that's what you ask about. Thank you. Thank you. Hello. Thanks for the presentation. And I'm right here. Where do you scan it from? Like, do you have like a provider, or? Yeah, we have some autonomous source, and our autonomous like API addresses, I cannot tell you by memory, but we have them on the website in the policy section. You can see them. And the provider, we've agreed with the provider, and currently this is Selectel. Thank you guys in Selectels, and Biget also company. Thank you for staying with us. Cool. Did you have any cases when you would be banned by companies? Yeah, actually, in our policy, it's even written how you can ban us. It's a normal practice. We say, this is what we do this for that. If you guys want to ban us or to delete your outcomes from our scan, please let us know, we're going to do it for you. And my second question is, how many flows do you launch in HTTPX? And how is it going?
Я сейчас, честно...
It's hard to say just off the top of my mind right now, but I believe that the metrics are being specified for the hardware, because we have on top of all of that we have the non-stop like a pen testing service, like a pen tops, like we're diving deep in certain companies. For each machine, for several iterations, metrics are adjusting themselves to squeeze out the max possible outcome. We do not have any specific numbers about that. Thank you. And my final question. Have you had any problems when parsing HTTP answers with coding, when you would say different coding in answers, and how would you deal with that? What would you do about that? Yeah, it's a question about HTTPX, right? Yes. Yeah, we've had this problem because HTTPX by default, 168 version, there were only Chinese code for recoding. We've written our own module, and we basically expanded the number of codes, and now all these Cyrillic codes are being recoded. That's cool, thank you. Thanks a lot. And yeah, a bit of context. I'm going to make it in 3 minutes, and I'm going to come up you. I'm also writing my own software. I have an experience in redoing project discovery projects. And now I have a whole bunch of questions. Number one, what kind of language your program is written on? It's a Go. Now that's cool. That would be awesome. And second question, you were saying that you've decreased targets by 1.5 because it's like 4x4 mostly. If elves and sysadmins will be able to fix it up, are you going to show it? Yes, we've included those targets from the constant scanning, ongoing scanning. But indeed, what if something showed up? We're going to reboot the scanning and see, has anything popped up? Is there anything new? And we have this table with a statistical report. It's being upgraded constantly. And I want to say that based on my experience, unfortunately, nothing new is shown up. And the main block would be cloud services. And the feeling is that they're like a one-time only, because if you have a domain name and the prefix is like UAAD, like a random kind of prefix, and we show it, we went there, and then we got like an empty response. And it doesn't matter how many times we would inquire, it still comes back empty. Well, any predictive models, statistical ones, to be able to feed them up, by the real raw data. Actually, our brute force, even by the ports 64K, it's always running on the background with a very small rate. It's finishing the scanning what our predictive model did not guess. And then it's being fed in the real time into our model, and it's kind of being upgraded. The same with the HTTPX. And the final about HTTPX, did you have any problems that you would be blocked for the HTTPX by the user agents? And yes, we write our own user agent. In all of our checks, it says like, hey, we're cyber okay, and like if you want to block us, you can block us, because otherwise we're all good and legitimate guys. Of course, we're trying to go by the Chrome and not to be blocked as much. What I mean is by headless. And the second thing about the vaporizer, there is a hardcore, like a concise version. And we also, the same engine in the cokmap, which Alex shared about that, we've attached it to the HTTPX because it provides much better detect. Thanks. I'm going to see you also on the sidelines, guy. Thank you, Wei, for like 1 minute and a half. Hello. Thank you for the presentation. I missed some of it, or maybe my questions have already been answered. And my questions are, number one, do you research network asymmetry? Because now internet is falling back into SIGMIC. What RUNET looks like from the USA, Singapore, and the UK. We do not have this task, but actually, if you want to get some trustworthy picture of a certain region, now you have to scan it from the inside and also from the other 2 external points, like a 3-point scanning minimum. But within the RUNET, which is a Russian segment of the internet, is that fully symmetrical from different global, regions? You know what? It depends on who is going to give you right answers, is going to get imprisoned, 10-year prison term. You have to send these kind of questions to TPSU. I think this is the Russian or Gossopka, Russian government internet agencies. I don't even know this word. And next question. Before you moved to the table model for this storing data, have you tried the 4G graphs maybe? What kind of data you're talking about? It's about domain. No. Yes, Neo4j is definitely a great database, and why we decided not to use it at the time, because it has problem with scaling up. You cannot just, just slice it. And we wanted to be on the safe side with this, and again, we have quite a big data volume, and probably one of the best solutions which we can do it is a ClickHouse. If we want more or less to make analytics based on the data, as long as you do not put the select stars. Yeah, makes sense. Cool. And one more question. I guess maybe 2 sub-questions. How often do you do scanning? And how do you store this like delta? What depth and do you pay attention to flickering holes? Like sometimes they have like different data. Now, we do scanning of the RUNET every 24 hours. In terms of depth, we store it according to the regulators. I do not know who is the regulator and what the requirements are. But again, as an analyst, and those kind of flickering nodes and weird kind of web service where the public services are also, it's a separate thing that we haven't shared. Thank you. Thank you. Hello. Yeah, the final question, please, folks, because the time is up. How do you find with the mistakes of the first and the second kind when scanning IP addresses? Well, you see the first and the second kind, I mean the false positive and false negatives. With the false negatives, we've always been comparing ourselves to somebody or something. It's an open, right? False negatives, you do not know. You do not know that this host exists. You just come and you look. I mean, we compare it to others. We have a separate product, which is basically with a shot, and others just seeing if we are matching, if we're better, if we're worse. And so we analyze several points, and our analysis, we do analysis of several providers, and also like a quick scan, slow scan, predictive scan. We collect all of those, and when all these things will be combined, we can see the full picture. As for the false positives, on the scan of the port is being generated by those like honey traps. Mostly it's a trash, but then we are trying to decrease their volume by the early detect, and then again we are just trying to do this fingerprinting with a cokmap, and if it gave us a banner, then we have analytics on top. Like if somebody said that both, Cisco and VMware, of course, it's an interactive honeypot. And then on the stage of detect of vulnerability, if this looks like a more pentops, more deeper analysis, then of course we do more like heavy checkups. So this kind of funnel, right, of trying to get down to the truth. Dear colleagues, our time is up. Thanks a lot for your attention, for your questions, and for our answers. And I guess
с которыми вы еще подойдете.
Thank you for the questions which you are going to come up with, and we'll give you this t-shirts on the sidelines, right? And I've really enjoyed the organizational questions, household questions about the equipment, and also there was a question from the young fellow, right there. Yeah. Okay, thanks again.